Hi, my name is Daniel Gottschall. I'm with the Mathematics Learning Resource Center here at Villanova, and this is my video on translating functions vertically. Okay, so first of all, what do we even mean when we talk about translating a function vertically? Well, before showing in general what we mean by that, I want to just walk through a concrete example. Uh, So I'm going to define the function f of x is x squared. And let's say we want to graph that. So, okay, well, we know that if I plug in x is 0, 0 squared, 0. Plug in 1, 1 squared is 1. And for that matter, negative 1 squared is positive 1. Plug in 2 squared, I get 4. Plug in negative 2 squared, I also get positive 4. So oops, that's my point there. But we know a graph should look something like this. Alright, and then let's say we want to consider the function, I'll call it g of x, is x squared plus 1. What would be the graph of that? Well, let's again plug in the same points when x is 0. So I'll draw that in green. That would clearly be 0 squared plus 1, which is 1. So I can graph that there. I'm put it in green. Let's say when x is 1, g of 1 is 1 squared plus 1, which is 2. And the same thing would be for a negative 1, because g of negative 1 is negative 1 squared plus 1, which is 1 plus 1, which is 2. When x is 2, I have g of 2, which is 5. Just plugging in the x values into the definition of g, and I'll skip over the same thing for g is negative 2. So a graph would look something like this. Alrighty, and then let's also define the function h of x equals x squared minus 1. What would the graph of that be? Well, when x is 0, h of 0 is going to be 0 squared minus 1, which is negative 1. When x is 1, h of 1 is 1 squared minus 1, which is 0. When x is negative 1, let me scroll below so you can read that more easily. H of negative 1 is negative 1 squared minus 1, which is 1 minus 1, or 0. It makes sense since we're essentially squaring each x input, that when we switch the sign, we get the same output. So I'm just going to do x is 2, h of 2 is 2 squared minus 1, which is 3. And because of what I just said, I'm going to just say h of negative 2 is also positive 3. And now if I sketch the graph, it looks something like this. Alright, so we drew these f, g, and h. We see the graphs there. We sketch them just picking specific points. But now I want to look at the graphs and think about what's happening here. So notice notice that basically the green graph, of course, it's higher than the black graph, which is just f of x or x squared. Um, but if I want to describe what's happening, let's look at this. Actually, yeah, I do want to pick a different color. Notice that each point here, like for example at 0, the green point is 1 higher. Same here, one coordinate higher, one higher. So it's almost like every point on the F graph, the black picture, was shifted up one unit to make the green graph, which is x squared plus 1. So looking at this pictorially, you could almost say that g of x is just f of x shifted, translated even, shifted or translated vertically by 1. And then what about this pink graph? Well, we notice, again, I'm going to do a different color here. Uh, if we pick again x as 0, the pink graph, it almost looks as if it was shifted down 1. This point was translated down 1, down 1. Okay, so the pink graph essentially, so we have the black graph x squared. To get to the pink graph x squared minus 1, we translated the f down 1 unit. So this is what we mean essentially when we say a function is translated vertically. So if we want to think of it pictorially in general, if I just have any generic graph, let's say some loop f of x, I want to talk about translating the function up or down. Essentially, I'm just either translating it downwards or translating it upwards. So that's pictorially what we mean, translating vertically. And then what do we mean algebraically? How can we represent this process? Well, now we can go back to how we were thinking of each of these functions when we did by points. So like for example, to get g here, notice we picked like x is 0. I have 0 squared plus 1. I plug in x is 1. I have 1 squared plus 1. So notice really what we're doing to get g is that because basically this process here, what are we really doing? We're applying, this is just f of x, right? We're squaring x. So we could really rewrite g, and sure enough, g of x, we say that, x squared plus 1. So we could rewrite x squared as f of x plus 1. So this, and we saw from the pictures that this really means we're shifting f, it's translating f vertically upward by 1, which we have represented here. We notice the same pattern with h because I can rewrite h of x as substituting f of x for x squared minus 1. And sure enough, the graph of h is translated vertically downwards 1. Compared to f, which again we have represented here. So how do we generalize this pattern? Well, you can probably see it. Let me call the function, I'll call it f2 of x, oh sorry, maybe f sub k of x. It just means another function. I'm going to define this f sub k of x to be f of x translated, running out of room here, let f of x be translated k units vertically. Then what would our formula be for fk of x? Well, based on our pattern here, we clearly have f of x, and then if we want to shift to k units, we just add k. Alright, so that's the main point of this video, that to shift a function, I keep saying shift, the title of the video says translated, either way it's fine. If we want to translate the function vertically, we basically, by k units, we can just in general add k to the function. Alright, I'm going to do another video, I'm going to do several more videos on functions, but the next one will be on translating functions horizontally. So don't miss that. Thanks for watching.